Yeah, he gave up this water for you because it's
you see the
Last one, this better fixes my voice.
what's that?
It's my last thing to keep speaking.
Should we start? Yeah. Hello everybody, I'm Nikos Mavrogiannopoulos and this is Wouters. We'll present you about IPsec and SSL VPNs, how to set them up in Fedora and CentOS or Red, it's pretty much similar. And yeah, it's a workshop, so it's pretty much not, at least the first part will not be much of a presentation. You will have to follow the instructions and try the stuff in your laptop. The second part will have some presentation as well. And so in the first part, 45 minutes, we will present the Openconenct SSL VPN, and the second part it will be the IPsec Libreswan with IPsec VPN. So before we start, a few points. There are two types of VPN, side to side. When you connect a LAN to another LAN, a remote site to another remote site, and remote access. Remote access is when you go outside your work and you want to connect to your LAN and use the resources from your work. When do we need which? When should you choose IPsec or an SSL VPN? SSL VPN is very restricted. It can only be used. It's only used for remote access mainly, unless you are a very small site, you want to use IPsec for site-to-site communication. And why is that? First, SSL VPN is very easy to set up for remote access for a user. Many SSL VPNs will just load, the user goes to the browser, connects to a site, and he's logged in the VPN using a browser plugin. So as user-friendly, it can be made a lot, and it has an advantage that it can tolerate, it can operate under very broken firewalls. So if the firewall blocks everything except HTTPS, you can still connect with an SSL VPN.
Which means you can also use it to circumvent network restrictions of being allowed to use a VPN.
Yes, in fact, a lot of Chinese use Openconenct just because they want to get out of the firewall of China. It's a bit more flexible in applying various restrictions to different users. For example, you want to put them in a particular C group or put particular bandwidth limits. I don't know whether this granularity you can do with IPsec.
You can do the same, yeah.
Okay.
Usually it's done with X5 certificates, where you put like sales in one group and programmers in another.
Okay, so this is not entirely accurate. IPsec has the advantage because everything is done in the kernel. You can have the kernel, you can do everything in the kernel. You reduce context switches, and it's a bit faster. It's more efficient when you use it for handling a big load. It has some better privacy than TLS. It's a protocol issue. SSL sends a certificate in the clear, while IPsec encrypts the certificate before the connection. So a passive attacker will not see who is connected if you use certificate authentication. Okay, that's pretty much the introduction. I don't know if you have any questions. If not,
Sure. Talk a little bit louder.
Yeah, there's no microphone. If you can come closer. So, I will start with setting up the client as an introduction. It's the easy part in Openconenct. So, I don't know how many of you have Fedora to use to start installing the client. And we will you will set up a simple client with a username and password authentication. So you'll connect to a site which accepts a username and password. We have created users with that name on this server. So there are 8 users you can use. You can select which one to use when you connect. And now we go to the command line client. You need to install it first in your Fedora. The command is yum install Openconenct. You can actually watch it from here, or you can, if you can see the small letters there, you can connect to the Etherpad directly.
It's etherpad.wikimedia.org/p/openconnect-vpn-workshop.
So if you raise your hand for a moment, when you do that installation, I will have an idea of how we are progressing, because there are many.
So have people here set up VPNs before, or is this all new for them? Yes, no?
If you have set up a VPN before, any kind of VPN, just raise your hand. Okay.
Anyone used Openconenct? No, anyone used IPsec? So most people used OpenVPN.
And after you install the client, you connect to the server using this command line.
So is this what is that? Server cert?
The server cert is you can skip it, but it will avoid a warning, but it doesn't know the server, and then server certificate.
So this is public key, effectively, in hash
Hash of the public key, yes.
Okay.
Yeah, actually you can skip it and you can type yes. So you have a smaller thing to type.
If I skip it, it asks for no password.
If it will ask for a password because it's username password authentication. The users are.
What's good?
Yeah, the user is this. If you use user 1, and the password is exactly the same as the user.
Please, can you read one more, the name of the Etherpad, so I can...
Yeah, it's etherpad.wikimedia.org.
Etherpad. Maybe you can paste it to the pen.
Yes, that will be
Smart.
After you connect, how do you know it works? You should be able to access the internal network, and that will be by pinging. You can test it by pinging this IP address, and if DNS works, you should be able to ping.
Sorry, 1 more 0 there. It's 100. 100. The 10 should be a 100.
100?
Yes. The address range 100.64 is a special range used for carrier-grade NAT. So it's a reversed range, and it's never meant to leak on the internet. So it's sort of like RFC 1918 space, except most people don't use it. So using that address range on your VPN avoids conflicts like when if you're behind NAT and the Wi-Fi range. So of course I shouldn't have told you this range, but now everybody will start using it.
Do I need to change the server configuration, or you have already changed?
I put one under them now.
Okay. Let me test it out.
And I am getting systemd journal d at defconf nox.ca PAM auth authentication failure from OC server. Someone's using wrong password.
Or wrong username.
Yeah, I typed the VPN test one as a password.
I'm not able to connect at all.
So there's 2 users online.
Try different users, maybe.
Huh?
Oh no, there's 4 now. Okay.
It doesn't seem to work. Yes,
I see another authentication failure on the server.
Yeah, it's blocking you?
There's some kind of a cookie problem. This does not ask for it.
There is some protection in the server if it is being flooded by the same IP address. So I don't know if we all share an external IP address. Actually, yes. Okay. I'll have to change the server configuration so it accepts.
yeah, it seems that the server is rejecting.
Okay, I'll disconnect everyone already connected. Does it work now?
Yeah.
It was passport.
What is the password?
The same as the username.
VPN test 1, 2, 3, 4.
But unauthorized. Same username also.
So now I see failures again. Yeah.
I tried to VPN test one and typed.
Nikos, the server is still giving authentication errors?
Maybe there are some typos and because I was able to get.
I think maybe if
Yeah, I was not
one
running it.
person is already online, maybe the second
there
one
is a
gives a
maximum
failure.
16 users per username. So you just select randomly from 1 to 8.
Did anyone get to the Firefox page?
Yeah.
Doesn't work? Or?
It works?
Not for me.
What does it display? Did the ping work?
I can't even connect.
Try 6. VPN test 6. Test.
So there are people who got the ping working?
Yeah.
Okay, but not the web page.
Yes.
Even though as well, it works.
Web page as well? Okay. So this DNS name doesn't exist in the public, it only exists on your own VPN. So it's a confirmation that you're actually using the VPN.
Has someone a problem connecting?
Yeah.
Who?
I am.
Oh.
So I get this.
Strategic customer.
Yeah. So the server, because basically, which is disabled by default. Failed.
Unauthorized. Which username you use?
7.
7. Try 3.
Unauthorized. Same thing.
I will lift the limit of users. It's stupid.
Oh, I'm in with 4.
Okay, good.
At least it gave a different output.
I'm increasing the number of users to. You should be disconnected now. I started the server, and but you should be able to connect with any username now. It wouldn't matter. So okay, is anyone having still problems to connect, except the disconnection that was intentional? Okay. The second part is you can do the same thing with Network Manager. If you have Fedora, you need to install the Network Manager Openconenct plugin. This is this part. Network Manager does Openconenct. And I've made some screenshots which can guide you to how to set it up with Network Manager. You go to VPN settings. Ignore it's a bit peculiar how you find this. I just go to the overview screen and type VPN, and it should pop up. The advantage of Network Manager is that it doesn't run as root, so the connection is done not as root, and only the parts that need to be executed as root are executed as well. So it's a bit safer and more well designed on the command line client. And if you don't have a PC, you can actually do it from your Android. If you have iPhone, you can still do it, but it's not an open source client.
It's just stuck.
It's just like doing timeout after that.
Yeah, it's like established GTF connection.
Yeah.
Daily timeouts.
But
It's connected.
Oh.
So it's supposed to be like that.
oh, okay. But so checking ping from other.
Mhm.
Yes. Okay.
In the server overview, this is what the administrator sees. Let's say who is connected. He can see the user from which IP. Actually, everyone here has the same IP. That's why this issue was. And how long he's connected. We'll see that in a moment when we go to server setup. So anyone had problem with the network manager step?
Yeah.
I can connect, it says it's connected, but I cannot access the website.
Yeah, the DNS is not
Yeah.
updated for some reason. I think because the ping works, but you go to IP address.
Did you ping the DNS address? What did it say?
You won't modify the result.
If you copy your result,
Yeah, you don't modify because this.
Okay. So
that should have been done automatically. Let me check.
so there is no network manager Openconenct in route.
It's red. Yes, there is one. It is in a pedal.
Okay.
Connect support legit networks, top devices.
You can do a simulation of that. Yes, it's called proxy ARP. There are some instructions in the Openconenct site how to set up proxy ARP, and you get an IP that it's within the LAN that you are connected.
I have to manually specify the resolver there.
On network manager.
In network manager. I don't know what.
Yay, new bug.
Yeah, I don't know. It should have been there. I mean, it was working 2 days ago, so I don't know what to say.
Well, maybe it because I have the.
Do you have the other one open?
I have this setting in. I have this DNS mask that I use caching the DNS server.
Oh, you want unbound?
You have modified it.
Yeah, I have modified the default configuration, so it uses the DNS mask for.
Okay, I'm taking a note of that. I don't know whether it affects it or not, but
It works. For example, it works, however, on Red Hat VPN. It works normally.
it should have worked, but because it's just a casting thing.
I think so. It works for the Red Hat Open VPN, and I don't have any manual setting. I don't know why.
Okay. I'm going to the next step. You can do that the same from Android if you don't have a laptop, or if you have Windows, probably not here. There is also a client you can use. The same for Mac OS X. Another thing you may want to try is certificate authentication. There are some test certificates you can use to connect to this server, and the command line is this one. But I'm going to skip this test for now. I'll go to the server setup directly. You can try this now or later, but I'll go to the server setup to make sure we have time.
Yeah, the test server will be up during the entire conference, so feel free to use it and play with it.
So to make a server like the one you connect, you need to install Openconenct first, the Openconenct server. So in Fedora, that will be with this command. I will type it now.
DNF.
It works on CentOS as well, so I like Yam better. So after you install it, OC server is Openconenct server. After you install it, you need to create a server certificate, and a CA. This can be done automatically if you don't really want to buy one. So this will generate a certificate for the server, this command. And all you need to do to set up the server is edit this file afterwards, after you install it. Here we'll set up a server with password authentication. It will ask the users a password, and we instruct to give them these addresses from this network, just randomly selected by me. And it will send the DNS server for the clients to be that one. It's a random IP. The server will not work in practice. I mean, you have to set up with real LAN information there, but this will be a test server. And you will need to specify the port that the server will use, because this is SSL VPN server. Typically, the default port is 443. I don't know how familiar you are with VPN. With VPN, you can either tell the client to use the VPN server you connect to for all routes, so for default route, so everywhere the client visits, it will go through the server. Or you can just tell the client that I serve this IP, this set of IP addresses, this prefix. So if you specify this, You just tell the client that, okay, I'm serving these addresses. And don't try to connect for all internet connections to me. If you want to do the alternative, you do this option. You get the command line then, or then network manager?
Command line. So one should rather use IT address instead of the name, otherwise one lost the connection trace.
Okay. Yeah, but if you press Control C and you reconnect, it works.
Otherwise it's still times out and twice again.
And just press the reconnection. Yes, network manager is better in that. The network manager connection.
What I think is that the reason why it doesn't work with the caching DNS, the default setup, because you don't, basically the network manager doesn't know how to, if I don't want to have DNS for everything to be forwarded to your server, then it doesn't know which domains are, for which domains it should restrict the.
So network manager doesn't send this information, you mean to the caching server? It should have sent that, because the server sends all the information, network manager is supposed to specify.
If you specify just this information, there is no information which is the domain for the DNS.
Yes, if you only specify this, but inside the configuration, you can set which are your split DNS domains.
Yeah, and did you specify it on your...
Yes.
And I know why it would be. Then it must be a bug in the plugin for that sort of thing.
We have 15 minutes. I'll take 10 minutes more. Okay, let's... who is in this part of the test? Just raise your hand. Okay, and after you set up a configuration file with this information, you need to enable the ports in the firewall. In typical Fedora, you just need to open the 443 port from firewall D if you use this port.
I have specified IPv4 network range, but it's showing that your network IPv4 is not enabled.
You only put that information. You have to edit the original file and just there was there should have been file.
There was no original.
Did you install the SSL? RPM, QVL, do RPM, QVL, yeah,
That there was no.
You do it?
No,
Just do it.
no,
Slash and In that case, it will work. If you have it, sometimes you may want to check whether someone is connected. So that's one thing I will do. So if it exists,
I think that you have a bug in your configuration of the server because this is what is getting by default. And this one is right, but example
could be, but you said you work with the client, with the command line client.
Yeah, because it did not. It just replaced the
whole server.
The result, the DNS server in result 1.
Okay, it could be because the configuration was changed for the 100, so I don't know if there's something there. But anyway, let's move to the server side, and you can start Openconenct server using systemd. And in a real world scenario, you would like to set up your firewall in a way that communication between VPN users and your LAN is allowed. This is an example using Sorwall. I mean, you can use whatever firewall you have. And the interesting for me information is after you set it up, there's some commands which allow you to see the status of the server and how many users are connected and how much they're downloading and everything. So the status command shows you something like that. That the server is online for so many hours. There is one client connected. How many IPs are in the ban list? The ban list is the thing that stopped you from connecting in the beginning. If there is a single IP connection all the time, it blocks it. And that is the status page. And you can also get an overview of the connected users. So with the OCCTL tool, you type show users in it, and you see the username, the group it belongs to, the IP he connected from, the IP he was given in the VPN, the device he's using, and cipher information. And you can even get specific information for a user, which is more detailed. You can see which client he connected with. This is the Openconenct client, for example. It can be another client. How much he's downloading, the average bandwidth he's using.
So I'm stuck on the authentication. I don't see...
Of the server or the client?
Yeah, setting up the server. I want to add a user to the OCServe S3D, WD. What's the format? Or I can
there is a tool OC passwd that you can use it to add users and set their password.
Okay, thanks.
I'll write it in the etherpad. Are we on time? It's already 40 minutes? Yeah. So let me check. You can use the Etherpad even after the talk. And another thing, you can disconnect the user, and there are some other examples to set up the server with certificate authentication and stuff. And the interesting setup is if you use Kerberos in your LAN, if you use IPA, for example, there's a recipe how to set up OSI server in a way to do sync sign-on. So when you connect to the VPN, you're also connected to the LAN using Kerberos, and you can see all the services without a second authentication. So I give the floor to Paul, who will tell you about Libreswan and IPsec.
They told us 4x3. So I downloaded the 4x3 template, but it's quite different. Okay. So I'll give you a really quick primer on IPsec, then show you the configuration examples, and then we can just build tunnels to each other or to the same server that we've been using for the Openconenct tunnels. So the different part with an IPsec tunnel is that there's two parts of it. One is the command channel that happens in userland. It's called IKE, the Internet Key Exchange. And the actual crypto part of the packets is done by the kernel, not by the userland program. So that happens inside the kernel. So IKE is the command channel for setting up IPsec tunnels, and the IPsec tunnels actually do the encryption. Since IKE is going to negotiate like crypto material, it also needs to be encrypted itself. It's a little confusing. So the IKE command channel is encrypted, but it's only used to set up the tunnels that provide encryption. So for Linux, the way you talk to the kernel IPsec subsystem is to use the netlink interface with the XFRM subset. The standard way on most other OSs is the PFKey interface, but it's no longer maintained in the kernel, so whatever's left there is sort of a half implementation. It's also known to lie about what the kernel supports. So if you, for instance, have certain crypto algorithms, the kernel will always say that they don't exist, or will always say that they do exist. So you cannot really use them. Use the IPXFRM state and IPXFRM poll commands to get the raw kernel information about IPsec. And if you want to do any IP table rules, you can specifically match packets that came in encrypted but have since been decrypted by the kernel by using the -m policy and the --poll IPsec. So you can, for instance, say, I only want port 25 traffic that has come in over IPsec. So then you can block port 25 for the plain text, but it's a way of matching the IPsec packets after decryption. So it's sort of it's a taint that keeps with the packet, so you know which packets were encrypted before. There's two versions of IKE, IKEV1, IKEV2. As you can see, they're both really old. So obviously most people still use IKEV1 because it was working well enough. Only in the last 2 years have we seen a dramatic increase in IKEV2, mostly because of iPhone and Android. The IKE runs over UDP port 500, and to work around some helpful devices that vendors created at some point that messed with that port, they also moved it to 4500 for net traversal techniques. Two more terms you'll hear regularly is security associations. That's what they basically mean when the two peers have come to some kind of agreement and they have an open command channel to each other. It's called a parent SA or an IKEV security association. In really old terms, it's also called a phase 1. And that's the part where authentication happens in different ways. I appreciate key RSA, X59, GSS API. There's also AAP plugins and other things. The IPsec SA is the security association that both systems have about the IPsec encryption itself. So they keep a copy in user land just to know what's in the kernel. If you look at on the wire, the IPsec protocol uses protocol 50 called ESP. So a lot of admins make the mistake of not understanding that it's not port 50 because they're used to dealing with TCP and UDP that has ports. ESP does not have any ports. It's protocol number 50. All the other things, I guess you can mostly forget. There's two modes, tunnel mode and transport mode. Tunnel mode is a full entire packet inside another packet, where transport mode is just the packet itself being as much encrypted as you can, but of course you cannot then encrypt everything because then you cannot know where the packet is going to. So it leaks to source destination, obviously, and some other header information. Transport mode is mostly used because it saves a few bytes because you're not adding an entire packet inside a packet. But usually it's not really needed. If you're at the end point of an IPsec tunnel, usually people lower the MTU to 1200 or something just to avoid the 10 layer of encapsulations that happen on the way, between your ISP and the world. So usually you use tunnel mode. Authenticated header was also a way of doing authenticated packets but not encrypted packets. And nobody should use it anymore, but again, whenever the IETF tries to remove it, there's a few people that stand up and say, no, we use this, you cannot remove it. So it will never go away, but it's not really used by anyone. So all of this, luckily, you don't really need to know because all the defaults in Libreswan are set in such a way that they use the right things. So installing Libreswan is pretty simple. Just install the Libreswan package. The one maybe confusing things is that the service is not called Libreswan but IPsec, which turned out to be a good thing because originally this software was called FreeSwan and then it was called OpenSwan and now it's called Libreswan. Luckily the service name has never changed. Also, since FreeSwan actually started in the mid-90s, there were no advanced init systems, so everybody had to type etc init.d, rc3.d, IPsec start. So we already built our own wrappers around it, so we can just do IPsec start, IPsec stop, IPsec restart. And of course now it will look at what init system is running, and if it's systemd it will call systemctl, if it's running upstart it will do the upstart thing. So if you want to do the Network Manager GUI side for the client, you install Network Manager Libreswan GNOME, or depending on if you're on an older Fedora, you still have to use Network Manager OpenSwan GNOME. We made sure that both packages support OpenSwan and Libreswan. OpenSwan has been obsoleted by Libreswan, so depending on which of the ones available on your system, depends on your Fedora version. So let's get to the configuration. This is the full configuration needed for a simple tunnel from one IP to another IP. So one thing that might also get some little used to is that we're using the terms left and right because IPsec is a peer-to-peer system. So there is no source destination or there is no server client. So when they designed the software, they decided to call it left and right, where left means the server that's on the left side of your diagram. And of course, if you turn over the diagram, it's the other way around, it's the right side. And so it's arbitrary. You can decide whether you call it left or right. Once the daemon starts, it will look at all the IP addresses it has configured, and it will figure out whether it is left or whether it is right. So this also means that you can take this configuration to the other machine without changing it and use it there too. We thought it was really clever, but it's caused a lot of grief because people just don't find it intuitive to use left and right. Auth by secret means like a pre-shared key, and you can drop in a secret file in the IPsec.d directory where you put the IP addresses in, and you say PSK for pre-shared key, and then the secret. And once you do this, the only thing you need to do is restart the service, and your tunnel should be up. So if people want to try it, then we can try with the neighbor, or I can talk a bit more about more configurations first. Any preference?
How do you specify multiple servers in the core? Like, you want 3
Okay,
servers?
I'll go through more configurations, and then this will come up. So if you want to add a network to a subnet to a subnet, and the only thing you need to add is left subnet is and right subnet is. And if you want multiple subnets, it's actually right subnets with an S and then a comma separated list of multiple servers. And then you can explode them as much as you want. What we call subnet extrusion, this is actually what I use myself as well at home, is where you call one side the subnet 0/0 and the other is your subnet. So what you're basically doing is you're moving a subnet to your other location. So for instance, this range, 192.110.157 0/24 is a range I own in Amsterdam. And so on the Amsterdam server, there is this configuration. And this is my DSL IP address at home. And so it says I actually have this subnet, and every destination from this packet to anywhere in the world has to go through the tunnel. So basically, these 16 IP addresses live now in my space in Toronto, and if you do a trace route to it, you'll see a trace route happening to Amsterdam, and then a really slow hop, the last hop, which looks like a single hop because of the IPsec tunnel. And it actually goes all the way to Canada. So this is how you move a subnet around, which is a really useful feature. Especially if you want IPs in your home and your ISP only gives you one. So configuration so far we've used that pre-shared keys. So this is one where we're using RSA. So you run IPsec new host key that just generates a new RSA key for use with IPsec. You can display it by using IPsec show host key, and then you can type --left or --right, and it will just show you the line that you have to put in the file that specifies the key. So the output of IPsec show host key you can send over email. It's just a public key, so you can exchange it. You can come up with a random ID. It's not really used. It's only used for matching, so it doesn't matter. So for instance, Paul and Nikos. And then now the configuration is slightly changed. Left ID is specified and right ID is specified. And then left RSA SIG key, and then this is shortened. It's a really long blob of a key. And right RSA key. And auth by is RSA SIG instead of secret. So now you're using RSA, which is much more secure than using pre-shared key. And so there's no entry needed in the secret. So you don't need the secrets file, because once it generated that RSA key, it stored the private parts of the key in a specific NSS database that's stored in the etc IPsec.d, which can be protected by FIPS passwords and other things.
But is it on both? How it gets on both sides?
Sorry?
How it gets on both sides?
So you exchange with the other end the public key, which you when you do IPsec show host key. Actually.
Okay.
Where are you?
So you create. Do you need to create that on both sides? A new host.
Yeah, the new so new host.
Them.
Yeah, both parties generate an RSA key with new host key. Then they run show host key to just get the public key, and you exchange them.
Oh, wait a minute. And then how you apply them? It's like, is there a command like apply, like use this key, or you just put it into the configuration?
You put it into the configuration. Like,
Okay. Okay.
I'll go out of full screen mode on the presentation, and with a terminal I can show some more things. So another feature, on-demand tunnels. So if you do a subnet to subnet connection, you might not want to have it up all the time. So if you want to bring it up only when there's packets there, you can just change to say auto is on demand. Basically instructs the kernel and says these packets may not leak out. If you get a packet for this, go talk to the IKEV daemon and give us a notification, and we'll set up the tunnel. The one problem with this is that the first packet that actually triggers that kernel message is eaten by the kernel and dies. So if you're doing something like a TCP, or if you're doing a ping, you're missing one ping packet. If you're doing a TCP connect, you're missing that first TCP connect. I have been trying to tell the people that they should really implement a packet caching for this, so that they cache, at least 1 or 2 packets, so that once the tunnel is up, they can release the packets. But Herbert-Su has not been convinced yet that you should write the code. Dynamic IP. So for one, if you are on a dynamic IP, you can do left equals percentage default route. It will just pick up the IP you have and use that to go out. If you want the other side to be random when they connect to you, you can use right as percentage any. Of course, this you can't really use in real life, because if both ends don't know where to find each other, then it stops, right? So normally in these cases where you're both on dynamic IP, you make sure you have a DNS hostname that gets updated. And if you use a hostname for these, then they will also properly just work. And it will do, whenever it tries to bring up the tunnel again or re-keys, it will re-look up the DNS. So if it's changed in the meanwhile, it will find the new IP address. You also use usually auto equals add instead of start or on demand, because if the partner you're trying to talk to, the remote partner, is any, you don't know where they are. So you cannot initiate to them. You have to wait for them to initiate to you. So this is not a configuration that would be identical on both sides of the... This is a typical Cisco IPsec connection. So this is where we're basically emulating a Cisco server, which if you look on the Android, so on iPhone it's called Cisco IPsec, on Android it's called RSA XAUTH. It's basically the same thing. It's using IKEV1 with some extensions called XAUTH. So you'll see some new things. So this one is with certificates. So I didn't put the commands in there yet. No. So you import the certificates, which I'll show later, and you specify left cert. You specify it by the export name that was chosen for the PKSS12 certificate. You say left XAUTH server, left mode config server, yes, and on the right side you say client, yes. You can assign an address pool. Pick a bunch of IP addresses. You say write subnet as 0000 to get all traffic. And these are just some specific. You can give a DNS server, you can give it a DNS name for what domain you want to get DNS queries for. And you basically, so this is what I use to connect my iPhone to my home network. And this is the same with pre-shared key. The difference is usually you say remote peer type is Cisco to enable some Cisco tweaks. Usually those setups also use aggressive mode, and they're very specific. Cisco is very specific about the crypto parameters. The whole point of IKE was that you can send a whole bunch of proposals, and then the two peers will negotiate the one that they both like. but Cisco is more secure. So as soon as they see something that they don't like, they just stop talking to you, not to reveal any information, which is not what the protocol is about. So you used to have to specify it specifically. So this is one way of specifying two proposals. One is for AES-256 with SHA-1 with a diff element size of 1024, and the other one is AES-256 SHA-1 with the same group. They're the same. One should be 128. This one should be 128. So here on the slide. The ESP, so IKE is the encryption algorithms for the IKE connection. The ESP is the encryption done by the kernel for the actual packet encryption. The group name is specified as the ID. So what Cisco calls group name is what in IKE terms is really the ID of the client. So this basically this almost comes straight from my configuration to connect to the Red Hat VPN. So the Network Manager plugin, if you want to test it against the DEFCON server, you can just go to Add VPN plugin, then go to the Identity tab, and you basically fill in the gateway. You leave the group name out, and then user group password. The group password is the pre-shared key, and then username password is the same. VPN test 128. So once, when I was making these slides last week, I actually had to talk to some of the Network Manager people because they expect to deal with routing. So whenever we added a route, they were sort of deleting them from us. So one side effect is that in the latest package that's in Fedora right now, when you disconnect your VPN, you'll actually lose your default route. But there will be a fix for that soon once they roll a new version of the package. Some quick commands to add your connection, delete, bring it up, bring it down, start or reset. IPsec --listen is used whenever you gain a new interface or lose an interface and things change, and Pluto, the IKE daemon, has to reorient itself to figure out who it is. So that should usually not be needed by the end user themselves. Some other useful check. IPsec verify will do a quick check on your system to see if the settings are right. There's some sysctl settings that could be weird. Forwarding might be disabled. Things might be RP filter. People know RP filter? It's a proc setting you can enable, which very smartly automatically drops packets that come from a destination they couldn't have possibly arrived on. So if you have like ETH0 with a 10/8 address, and suddenly a packet for 10 has originated on ETH1, then it will be smart and say, well, that could never happen. The routing tells me it should have come from ETH0, it can never come from ETH1. And so it will drop the packet. Unfortunately, the code is not smart enough to realize that a packet could have come in encrypted, got decrypted to another IP address, and then got onto the machine. So RP filter you always have to disable on an IPsec machine. IPsec WAG traffic status shows you, similar as Openconenct, how much traffic the users have been doing. The IPsec status command is what was never meant for humans, only for developers, but since we took up the easy name, everybody uses it. It gives you like basically a dump of the entire IKE daemon's internal. And IPsec barf is what we sometimes ask people to give us if they have a lot of problems and we want to understand their system. It actually makes a sort of snapshot of their entire system related to IKE IPsec. And the last two commands are for importing certificates. So if you want to do anything with certificates, you get a PKCS12 file and you just do IPsec import and it will call the proper cert utils or PK11 util for you. And if you want to see what's in the NSS database, you can also use this cert util command. But our real true goal is to encrypt the entire internet with IPsec. Nobody should be sending packets without encrypting them. So, so the Libreswan project, and this is what actually started the FreeIPA project in the mid 90s, was everything should be encrypted. So we call that opportunistic encryption. The term is a little bit vague now because people associated different things to it. But basically the idea is whenever you are going to send out a plain text packet, why don't you look and see if you can somehow build up an authenticated connection with it, an I connection, and then start an IPsec tunnel with it. As of last year, there's now even a possibility to do an unauthenticated IPsec tunnel. So you just say, I don't know who you are, but let's talk IPsec because, hey, the NSA is monitoring us and let's just try and encrypt it. So we have the unauthenticated one working. The old DNS one is not working, but we're replacing it with a DNSSEC one. And we're also working on the GSS API one, a Kerberos one. So that basically allows you to encrypt your entire LAN as a mesh. So whenever one machine in your LAN sends a packet to another machine in your LAN, the kernel will catch the packet, tell the IKE daemon, hey, you should set up an IPsec tunnel in there. We set up the tunnel, everything gets encrypted automatically. So you don't have to specify one configuration for each host in your network. Now that I can see if I can demo that. Although it doesn't really work here on the Wi-Fi, so I'll just log into another system. So this is actually the demo server that we've been using. So I sneakily already enabled. Why is it so slow? Okay. Wow, it's like being on the modem. Come on. Okay. So you can see that's already, okay, so one user connected with the configuration, and the three before they clear or private, you can see there, those are three other machines that have an unauthenticated IPsec, so they're anonymous. So they just happen to send packets, and those are oelibreswan.org. Oops. OE1.libreswan.org. There's a few of those. OE up to I think OE4 we have now. So those machines sort of continuously ping each other via cron to bring up the tunnels. It's our little testing system for this. But they also do this to the entire world. Now, of course, you have to remember if the other end didn't actually support IPsec, you don't want to hammer them every time to see if they can IPsec. So we do remember that for a while. So I'll see. So we call those things a shunt. So we place a shunt in the door to say like, okay, we don't do. Okay, so that's not a good example. Okay, let's actually pick the. Ah, interesting. Okay. Oh, I don't have my keys on there. Sorry, let me just find another machine. I think someone might have, another developer might have reconfigured these machines for another test.
Can I ask?
Sure.
What is better to use to manage the IPsec tunnels? IPsec outro and some attributes, or IPsec what's?
No, so if you want to just monitor the tunnels, the IPsec WAG -- traffic status is the one to use, because that gives you one line per tunnel in the output. Like the IPsec status one gives you a lot of details, but it's really hard to parse. You don't really want to parse it automatically. Ah, it's hard typing in a delay. Yeah, somebody installed some broken version of that. Okay, I'll try the last one. I run an open DNS resolver, which gets a lot of traffic, and so we use that for some stress testing. So that was guaranteed to have the right installed. So for instance, we found that you have to be really careful about logging. If you can't really even log like, oh, opportunistic tunnel didn't work in one line. Like on a DNS server, your disk is filled within 4 hours. God, now the network is even too slow. Anyone else have any questions on IPsec? Oh, here we go. So here you see a list of shunts. So it has tried to do opportunistic IPsec to all of those machines, and it has remembered this for about an hour or so that it didn't work. Now this list probably has like 64,000 entries or so, because it's my DNS server. So with the Wi-Fi here, my shell is now lost, I think. So anyway, so the goal is to have like a full mesh encryption both in the enterprise and, if possible, like internet-wide. So that's what we're currently working on as stream.
So if you want to use Let's Encrypt, isn't there a policy that they won't sign IP addresses but only host name?
So if we do the so we can do the opportunistic with XAUTH and certificates with Let's Encrypt. And then so we say, okay, we trust the Let's Encrypt CA.
Yeah, but they only sign host names, not IP addresses.
Yeah, but we just use their certificate. So once we connect to a server, to an IP address with a packet, that server will then, when we try to do IKE, will give us their certificate. And then in that certificate will be their name, which is not their IP address, but we don't care. Now what we can do, what I've been thinking of, maybe we should do an extra check where we look up in the DNS to see if that was actually their name or not. So that there's a little extra check that there's no man in the middle, but because anybody can anyone can steal routing and take over an IP address and get a Let's Encrypt valid certificate. But remember, the goal of opportunistic encryption is to encrypt when you would otherwise have sent it out plain text. It is never a replacement for like a hard enterprise encryption or like that you want to do properly. So like the Kerberos GSS API, has to be done properly. So there's no man in the middle possible. There's no token shuffling or other things happening.
Well, if you connected once, can you be sure that you're connecting to them the same thing another time? So if you
mean, do you want to do the SSH thing of the known hosts file?
Yeah, is there some way to be sure it's the same one you connected? You say there's no authentication, but can you at least be sure it's the same one, or would you have to exchange some?
You could, but how? But what do you do when it's not? Because like everybody on dynamic IP addresses, you will talk to different people with different sessions, so you can't really tell that they're somebody. Also, one of the modes we want to do is where only one side is anonymous and the other side is not. So traditionally, IPsec, both peers authenticate each other, and with the null authentication, it's now possible to be unauthenticated. And that's something that actually TLS had as an advantage. The reason so much HTTPS encryption happened in the last 10 years is because people didn't have to configure their own identity on their machine. They could just connect to the server, and it was their job to authenticate the server, and the server didn't really care who talked plain text or encrypted to anyone who's going to talk to it. And so IPsec was missing that mode. So by finally having this RFC out, we can now do the same in IPsec. So where a client can connect and go, okay, I'm just going to verify that server is really that server, that IPsec server, but I'm not going to even tell them who I am because they don't need to know. Okay, I think we're pretty much out of time. What is the...
Still have 10 minutes.
10 minutes? Okay.
12 minutes.
So if people want to set up some IPsec tunnels, go for it. Or some more questions for Nikos. Yeah?
One question. Opportunistic encryption, does it use transport mode?
No.
Does it use tunnel mode?
Yes. Because transport mode is evil and should die. Because with the presence of NATs, it's terrible. Because with transport mode, you're basically encrypting on the packet itself, right? So you're not encapsulating another packet inside. But then when you go through a NAT, these IP addresses get replaced for other IP addresses. So then you break the encryption. So the only case where transport mode really still is used is the L2P IPsec with Windows 95. And that's sort of a weird transport mode because it sort of also does tunnel mode. But yeah, no, whenever you say transport mode, I have to...
Even for IPv6.
Sorry?
Even for IPv6.
Yeah, it doesn't matter whether it's IPv4 or IPv6. So I mean, and really the only thing you gain is a few bytes. Like it's not like transport mode gets you a few bytes, and then
it relieves you from the overhead of having to just point the question. It's just like you're sitting next to each other and we talk
Right.
It doesn't matter if you use desktop or the town.
So if you want to do it, so the way the configuration of the opportunistic works. Here, let me just bring up a new shell that's local. So we define, first of all, we have a group called clear, which is the group that we never want to talk IPsec to. So this is where you can put your whitelist in, like, never do IPsec there. Then we have clear or private, which means don't initiate IPsec to them, but if they do IPsec to us, we'll do IPsec with them. Then there's private or clear, which means we'll try to do IPsec, and if that fails, we'll do clear. And there's private, where we go like, okay, we'll initiate IPsec and we expect them to have IPsec. And then there's block and never talk to them. So you can see here, these are just regular IPsec configurations. So if you want to go like, well, I really want to use transport mode, then you can just say type is transport. And then you have transport mode. If you really want to, you can do it like that.
Well, I forgot that.
Yeah, and then right, and then sorry. And then so in the there's a directory etc IPsec with the policies, and it actually contains the sitter addresses of what you want to do. So if I look at private or clear here, in this case we only put 0/0 in. And here, so in these files you can basically say, okay, this range goes into clear, this range goes into clear or private, or this range goes into private or clear. So you can sort of determine with whom you want to do opportunistic encryption. So I guess I'm supposed to throw these to anyone who asks questions. I think maybe they just had too many of them.
It's for other program too. So you can give up to free.
The proposals which peer sends to me.
So we actually just redid that upstream, where it will actually give you now in the regular log, so without having to add any Pluto debug logs, it will tell you the peer sent these proposals, and I have this proposal, and therefore we didn't match. Yeah,
it will be in the next one.
Next version will be in. It's already in the. If you pull the Git version from GitHub, it's already in. Yeah, we actually had to completely rewrite the proposal code. It was badly done. So, for instance, it checked every element with every element, and like it turned out StrongSwan sent a massive amounts of options. Like it's like many ciphers, many algorithms. So we spent, if you enable debugging, we'd spend so much time in the debug just writing all these proposals out that it was too slow. It timed out. So we redid the entire proposal code. So now we're really fast. And as a result of that, we can also just simply now print the line.
So great, I can now check if I have problem with the other side. And I
Yes.
can say, you send me this, and I.
Yes, and you no longer have to enable debugging. So it will already be in the no debug log.
Because I will forget it.
Can I ask you if you have some slides? You can publish on the drive.
Yeah, we can do that.
Thank you.
That reminded me of my talk in 2012 about Samsung. This is the web part.
Okay.
I just look at the slides and lots of the things were really the same. Road warrior use cases and stuff like that.
Yeah, because that all comes from
FreeIPA
FreeIPA.
or not?
So that all comes from, all those terminology comes from the FreeIPA days. So Strong
Yeah,
Swan
I
also
know.
forked from FreeIPA.
What is the difference? Are they still maintained? Strong
Strong Swan is still
one.
maintained, yeah.
I asked a couple questions. It's just going to be blue and blue.
Because the Fedora t-shirt, I guess they have uploaded them.
It's over.
I have enough with those.
One
Asi bude tam chytnout nějaký žrádlo, to slyším.
I
Já
just
jsem
clicked
rád, že to na moje věci.
Defcon person,
To se
but
snažím dožádat kafe a zpátky, nevím, pár minut.
but I will only put them on the demo server.
Do you want to talk about it or not now? Okay.
Takže vejte.
No, jakoby
Já vím, že to je.
Until tomorrow noon, roughly.
No, I mean today.
Today, we have some meeting at 5.
So my meeting is for 1 hour from now. So
Probably somewhere.
Where is the
I don't know where. that's a problem.
Otherwise, we need a wrapper around some document.
Yes, so
Actually used for
Either we have some place with
definitely
it's the second floor.
on this side. On
this side.
Okay. Okay, I will try to find it.
Yeah, because we know what happens is that the configuration file gets changed into, converted into a giant bracket.
Yes, for this.
and
Exactly.
when you told me you
Can I check the status of the IPsec kernels? Because project and stuff.
So the traffic status should show you. Yeah. So if you do traffic status,
It was like, okay, that discussion, that brutal discussion that went on, puts it on a different level, I guess.
Yes, and but I was not ready. Yes, I was not ready.
and then you also see how much, so when it was added and how much traffic it is. So 3 of your tunnels didn't have traffic.
The guys who were putting
Can I check if it is up or down?
These are up. Otherwise it wouldn't be in the
Yeah.
very hard to
So if I want to check some or create some graphs or check the state of the kernels, I guess I can grab this values.
Yeah. Yeah, the status was terrible. It was just
there was,
really internal.
There was a proposal to
Do you
do
plan to add some additional tops?
Oh, it's tab completion? And then I thought